All right, this guy, Nicky Tech, he said, I know you typically don't have the patience to sit through all of Gary's physics videos. Yeah, not anymore. But I think we are finally making real progress with this dialogue. He made a draft science video responding to this comment section. If you're in a hurry, simply skip ahead to the 5.5 minute 27-second mark of the following video. I hope you'll listen to his response re wave mechanics. They're reasonably stated without emotion. He's found some holes in your conclusions. Okay, well, so I've done that. I watched 2.5, 3 minutes of it. From that point, the video is something like Piro plus idiot equals Piro or whatever. So ignoring that. First of all, Gary says that the math has nothing to do with the mechanics. And I agreed. In this comment thread, I'm talking about this issue. Like, for example, a ball goes in a parabola. That does not say anything about gravity that's causing that curvature. It also doesn't say if it's gravity or, because of a magnetic pull between the two objects, right? But how it relates is that your mechanics has to be able to generate the mathematical pattern, and the mathematics is how you can like run a simulation with your physics and see how the pattern comes out. It might look roughly like the real pattern. It might be stripes, but the stripes on a zebra are not a diffraction pattern, right? So we could tell the difference. And when the differences are subtle, we use mathematics to look really closely at relative brightness and positions of bright spots and dark spots and so on, and medium spots. Right now, it seems to be under debate if light is a wave. And Gary seems to have the impression that the two-slit experiment is supposed to be evidence for light being a wave. No. Light having wave-like properties was already known through various other things. In fact, the fact that the light diffracts shows it's a wave. Diffraction is a wave phenomena. Because, why? Because you say, oh, well, electrons bend. Yes, any magnetic thing, all kinds of things can bend the path of a photon. Yes. However, if it's closer, it bends more. If it's further away, it bends less. Why in between are there dark bands? Why in some places there's dark bands? Because it should just be slowly getting dimmer the further you go away from the bright bar. There should be one bar. And then, in fact, if you shoot bullets at a hole in a steel wall, that's what you'll see. You'll see a lot of bullets in the middle and some weird stray bullets peppering the outside slowly. You won't see dark bands. If you do it 1,000,000 times so that there's enough bullet holes to make a pattern like you do with the light or the electrons, there wouldn't be the dark bands. The fact that you see the dark bands, the fact that prisms work, because see, in a prism, in glass, every different color is bent a different amount. And that's also a wave mechanic. When a wave hits a barrier, some of it will reflect, some of it goes through, wiggles the barrier. When sound hits a wall, some of it reflects and you can hear it in the hall. It's bouncing off. Some of it makes it through the wall and goes outside, and people outside can hear a dull boom, boom, boom of the sound. Okay, so when light, being a wave, hits a prism at an angle, each color is bent a different amount, and so you get the rainbow effect. That proves that light is a wave, or acting in a wave-like manner. And if there's a way for particles that aren't waves in any material sense to behave in that way, you would have to come up with a mathematical description that linked to that mechanics to that result, and then that result would have to match what we see when we do experiments. And that gets to this point about you saying that the math is not accurate. This is one of the things that there's really no reason for me to discuss it. If we write a simulation using the quantum mechanic principles here of a 1-slit, 2-slit, 3-slit, any optical apparatus, really any apparatus at all, but keep it simple because we can only do so much calculation. And we run that simulation, we will be able to generate the pattern that you see on the screen, right? The dots going one at a time, and it'll, through the mechanics that we have put out, creating events and then mathematically generating and simulating that whole thing, we will reproduce the pattern. Not where every speck is on the detector or versus the virtual detector. No, because that's the static nature of the universe. Every single photon's not going to land in the same place every time you run that experiment. But the banding patterns that we're talking about, they would be predicted exactly as accurately as has been measured so far. We've not come up with the detectors or measurements. And every time, every year, every decade, we get better measurements. And we've expanded that thing out dozens and dozens, I believe hundreds of digit places in that period of time. I know it goes out further than that. I'm saying it's been expanded in our lifetimes and not been, and what you see has not diverged from what that prediction is. So you're saying the math doesn't match the results, but it does, and that's the whole issue, right? That you could come up with another interpretation of theory, and that's fine. But as soon as you say a ball doesn't go in a parabola, it goes in some other shape, then you have to demonstrate why. I don't know why you hate parabolas, or maybe you don't hate the parabola or whatever. You think there's another reason it's going in a parabola. Then it's going in a parabola, though. You throw the ball, you take a photograph or a movie of it, and you trace out the shape it traces out as a parabola. And if you want to say, well, it's not quite a parabola, I would agree, because I know there's wind resistance and stuff that warp it off of that parabola. But that's not enough to say that, oh, so therefore, in my theory, it's a straight line. Oh, in my theory, it takes a spiral path. Because if you did do that, then you'd have to say, well, why, when you take a photograph, does, you know, a long exposure photograph, why does it look like a parabola? Now, somebody also asked, and I'll add this, you know, explain the diffraction pattern. Look, it's hard to explain the diffraction pattern, right? But people tried and tried, and they came up with a mathematical formulation that does explain it. And yes, it does involve interference, but it's not, quote unquote, the interference pattern from two slits, because that's two diffraction patterns overlapping and interfering with each other. When you have a wavefront going along and you see the water going up and down, really that's a compression wave traveling out from the source of, you know, a ball, splash in the water, create a little compression moment, it's spread out, right? And why does it keep propagating? Well, every point on that wavefront is wiggling, you know, up and down or left and right underneath the water and up and down on the surface of the water. They're all moving, right? And they're linked to the things next to them. They have surface tensions on the surface. Underneath, there's all kinds of electrostatic, they're little weak magnets, and they're bumping into each other, right? So if one part of the water is wiggling because the wave's coming through it, it's bumping into the stuff next to it. For example, the stuff in front of the wavefront that hasn't been hit by the wave yet, it's getting hit by that part of the wave that's right there. And that keeps it going forward. But it's not just hitting the part in front, it's also hitting the part in the side, right? So it's very much like, and yes, this is Huygens' principle, each point on that wavefront is a little wave emitter. They don't go backwards because they all cancel out and just go back to their rest position when the wave passes, right? And generally, if there's a long wavefront that looks straight, you know, they all start as circles, but you get a big chunk, or in the ocean, you could see a big straight looking wave. That keeps going because the wave, every part of the wave has something next to it, right? There's no empty space for it to jostle over there. There's something there jostling against it, and those forces basically balance. If you do the wave mathematics, what it is that you can trace out all the paths, and you can see where the troughs line up, and the timing is such that the troughs add up to either bright spots where, you know, they're peaking together, or dark spots where they're peaking at opposite times. Right? Now, when you have a slit or a barrier in the way and you cut off part of the wave, then you have that part of the wave that's on the edge of the slit that's going through. Hey, I just made it. The slit just barely didn't get me. You got my neighbor. On the other side of the slit, it's a wave, and this empty guy next to it on the other side of the barrier is going to start getting pushed. So it'll start to curve out in a circle because of this free space of water at rest. It can spread the wave to the side now. Before it couldn't, because there was already wave there. You can't spread the wave to somewhere that the wave already is. It goes through the slit. Now it can spread the wave to that side. So it slowly spreads out, right? But if you do the mathematics of all of those points in that limited line segment, generating what happens to the wave on the other side of the slit when removed from their neighbors, you will see there's parts where all these little emitters, basically because of the finite length of it, if you add everything up, there's a lot of cancellation going out, but then you get to the end where there's no wave front beyond there, and that creates points where the stuff doesn't cancel out just perfectly, and you see the effect of this self-interference, right? Of all the points in the wavefront, because their neighbors have been removed, interfering with each other, and that produces a diffraction pattern. And the math exactly produces a diffraction pattern, and it happens in any kind of wave or wave-like phenomena. And the two-slit experiment is interesting because, okay, we also have evidence that a wave is a particle, right? You could fire a photon at a detector that can detect single photons, and you go click, one pixel lights up. And yet only a wavefront, if you want a single thing to go through two doors at once, a wavefront is what you're looking for. Just like we had a tsunami, hit multiple countries at once. That was all one wavefront, hit multiple countries. Well, it's a pulse, a wave pulse, so a series of fronts, but relatively, compared to the size of the ocean, quite a local thing. Just like a wave front, it can hit the whole coast at once. So a wave can hit two things at once, and that's the weirdness. So, but the two-slit isn't what demonstrates the wave-like nature of light. What it demonstrates is the paradox. At one time, you can have an experiment where you show that light is like a particle. You have plenty of them as well that you could show it's like a wave, prisms, the diffraction pattern itself, all the interference patterns, all the wave type behavior and appearances, right? And in the two-slit experiments, you have both at once, and that is what it's like. Okay, I have to look at both of these at once. So they both happen at once, because it was hard enough to think that sometimes it behaves like this and sometimes it behaves like that. But I know Gary, sometimes he behaves nice and sometimes he doesn't. It might just be diet or the time of day, who knows? But to see them both at once, that means facing the fact that this is actually one phenomena with these two contradictory things, right? And there's literally nowhere to go or even try to go if you don't even admit that the mathematics of wave mechanics, and specifically in the quantum mechanical case where all the strengths of all the fields are taken into it, the strengths of fields as they've been measured and whatnot, the physical constants taken into account, predict exactly the patterns we see, and that's why the scientists say so and are so impressed with it. And it would have to be some weird phenomenal conspiracy that every graduate student, not even graduate, undergraduate, as an undergraduate in physics classes, I did the Michelson-Morley experiment, which itself relies on the fact that light is a wave that can interfere with itself. And that they've just all been incredibly stupid, or there's some conspiracy, or I can't imagine any other possibility that isn't just ludicrous. And I say this as someone that knows that current science is incomplete and wrong in some sense. That's obvious that we have contradictory things. We all should know there's things we haven't figured out yet. We all should realize that when we know of paradoxes and enigmas in the world, something explains them. We just don't know it yet. So all of these enigmas we don't know yet, yeah, they require new knowledge, right? Absolutely. And yet we can eliminate certain things. We know that the moon being made of cheese or the flat earth is not going to explain the two-slit experiment. So that's that. That's another subject matter.